The chapter which we are going to cover today is applications of derivatives. Now this is a pretty easy chapter which is just based on the concepts which we learned in the chapter differential calculus. We'll apply those concepts in this chapter and we'll see that this is a pretty easy chapter. The first question which we have in hand is, we need to find the sum of intercepts on the coordinate axis by the tangent to the curve root x plus root y equals 2. Now this is a question which can be solved in two ways. Either we could use the Cartesian coordinates x and y to solve this problem, or what we can do is we could change the parameter to theta. We'll try to solve this problem by both the methods. For the first method, let us try to solve it by the Cartesian coordinate method. Root x plus root y equals 2. Let us write the tangent to this curve. Differentiating this curve, we get minus 1 upon 2 root x1 at the point, let's say x1 comma y1, minus 1 upon 2 under root y1 dy by dx equals 0. So the slope of tangent, which we know is equal to dy by dx, is equal to minus of root y1 upon root x1. And also, since x1 comma y1 is satisfying the curve root x plus root y equals 2, we have root x1 plus root y1 equals 2. We'll use this result after some time. So let us write the equation of tangent at x1 comma y1. We have y minus y1 equals minus root y1 upon root x1 into x minus x1. Now this tangent is cutting the coordinate axis, let's say at point A and point B, and we need to find OA plus OB. For A, we put y equals 0, so we'll get x equals x1 plus under root x1 y1. This is the coordinate of point A. For point B, we put x equals 0, so we get y is equal to y1 plus under root x1 plus y1, or rather under root x1 y1. Now we want to find OA plus OB, which is equal to x plus y over here. So we get x1 plus y1 plus 2 under root x1 y1. This is the sum of intercepts, and this is equal to root x1 plus root y1 whole square. And from first relation, we have root x1 plus root y1 is equal to 2. So this becomes 2 square, which is 4. Hence we have obtained the sum of intercepts made by the tangent to the curve root x plus root y equals 2 on the coordinate axis to be equal to 4. Now we'll try to solve this question by using the parameter theta, and we'll see that question becomes pretty easy if we choose proper parameter theta. We are given that root x plus root y equals 2. So we can use x is equal to 4 cos theta power 4 and y to be equal to 4 sin theta to the power 4. This we have done since we know that cos square theta plus sin square theta is equal to 1, or k cos square theta plus k sin square theta is equal to k. Here we have considered this to be equal to k, and hence we wrote x and y in terms of cos theta and sin theta. Now our dy by dx as earlier was equal to minus root y1 upon root x1. So this is equal to minus of under root of this divided by under root of this, which is equal to sin square theta divided by cos square theta. So the equation of tangent becomes y minus 4 sin theta power 4 is equal to minus sin square theta upon cos square theta into x minus 4 cos theta power 4. For A, we put x, or rather for A we put y equals 0 to get x as 4 sin square theta cos square theta plus 4 cos theta power 4. For point B, we put x equals 0, or what we can do is we can replace the sin theta by cos theta. So we get 4 sin square theta cos square theta again plus 4 sin theta power 4. On adding both these, we get 4 times sin theta power 4 plus cos theta power 4 plus 2 sin square theta cos square theta. and this is equal to 4 times sin square theta plus cos square theta whole square, which is 1 whole square, that is 4, and hence the sum of intercepts we obtain to be equal to 4. Hence in these type of problems in which we have typical curves, not the simple curves in which y is explicitly written in terms of x, here y is not explicitly written in terms of x. Hence in these type of curves, what we can do is we can either solve the question by using Cartesian coordinates x and y, and more importantly we could also solve them by using the parameter theta to get the final answer as 4, and this is our final answer.